Okay, so today we're going to talk about size relationship. So thus far we've talked about perception of edges, being able to look at things and decide where the outside edges should be, where a detail would be, basically how to make lines that represent what you're seeing. Then we talked about positive and negative space, and that's trying to get the overall shape, the right size, and the right having the right curves on it, and getting that negative space around it correct. So next we're talking about size relationships. And this is probably the most important and probably, I would say, the most challenging of all the others. So let me explain it like this. When I say size relationships, let's pretend that I'm drawing a stick person, but I'm trying to make it correct in the way a human would look, more like a skeleton. So I'm going to do something and I'm going to do it the wrong way so you can understand what I'm talking about. So let's say I draw the head for my stick person or the skeleton. I draw the neck. I draw the shoulders. I draw from the shoulder to the elbow, elbow to the wrist, and I draw one of his hands. Go from this shoulder to the elbow, elbow to the wrist, his other hand, draw his spine, his hips, and then I'll do his legs. So obviously that's wrong. The reason we know it's wrong is because there are size relationships when you look at the human body that we all just instinctively know. We know, for example, that our neck should not be longer than our head is tall. A giraffe would have a neck that's longer than its head is tall. We know that our shoulders should be symmetrical. The left side and the right side should be roughly the same. We know that the length of your upper arm compared to your forearm should be not this exaggerated. So I've messed up all the size relationships. And when you see it in this context, you understand that this is not how a person should look. And it's easy to see when things are really, really off. But when you're drawing something and you get it close, but it's just not quite right, that's when it's kind of challenging. If you're drawing a face, both eyes have to be the same size if the person's looking at you. So if one eye is just a little bit off, it looks strange. So learning how to see size relationships and being able to draw that is probably one of the most important aspects of what we're talking about. Okay, so everyone should have 2 sheets of paper and a ruler. And I think all my rulers have inches and centimeters, but double check that yours does have both inches and centimeters. And for right now, we'll just look at one of the sheets of paper. So another thing to think of when we talk about size relationship, if we talk about negative space and I say draw something here, if I just say put something where my finger is, you don't really know how far that is. You don't know the relationship of where that's at floating in space. So we're going to use a ruler to draw a very simple image. Okay, so we're going to look for, or I'm going to explain to you how to find where things are located. So that's one aspect of size relationships. And then we're going to learn how to draw something smaller after we understand those size relationships. So let's just start. We're going to look at the bottom left-hand corner of our paper. Notice I have it landscape or longer from left to right. And we're going to start in the bottom left-hand corner, and we're going to use inches right now. So put 0 right on the bottom left-hand corner. And let's go over exactly 1 inch and put a small mark here on the bottom of our paper. So I'll zoom in so you can see that a bit better. So 0 on the left bottom corner, put a little mark at 1 inch. See if I can get this adjusted better. Okay, so next, let's go from that mark, put 0 on the bottom of the paper. Now we're going to go up exactly 1 inch and make a straight line. So this is 1 inch and this is 1 inch. So the size relationship is that they're both exactly 1 inch. So this empty negative space, when you compare it to the size of this line, they take up the same amount of space. Now they're going different directions. One is vertical and one is horizontal, but their size relationship is they are the same length. So let's go ahead and go over from the top of this line, go over 1 inch. And then go down 1 inch. So everything we've made now, when you talk about their size relationship, they're all exactly 1 inch. They're all exactly the same length. No matter which direction they're pointing, they're the same length. Now, let's start at the bottom right corner of this box. Starting at 0, let's go over 2 inches. And then put a little mark here on the side. So we have some empty space to the right of our box, and we have some empty space to the left. This is 1 inch, this is 2 inches. So this empty space takes up twice as much room as this empty space. So that's the relationship. This empty space is twice as large as this empty space. Next, let's go up 2 inches. So 0 on that line, go up 2 inches, make a line that's exactly 2 inches tall. And then go ahead, make a line going from the top corner over 2 inches and then down. So now if we look at size relationships, we'll see that this empty space that I'm pointing at is the same as the height of this box or the width of this box. If we look at this box compared to the one on the right, this box is twice as large. So there's a relationship between the size of these objects. Next, let's look at the top of this box, and I want to divide that in half. So if it's 2 inches wide, halfway would be 1 inch. So that means this side is 1 inch and this side is 1 inch. So half of this is 1 inch, and this half is equal to how tall this is. And I'm intentionally doing very simple examples. Most of the time it doesn't work out this nice and neat if you're drawing something real, but so we have the middle point. Let's go straight up from that middle point. Let's do 1.5. So you have 1, you have 2, and this longest line between 1 and 2 is your halfway point. And we're just going to put a dot right there. So this distance up and down is 1.5. And we're going to connect that top dot to the left side and the right side of this box to make a simple little house. Then let's make it 1/2 inch wide. So 0, between 0 and 1, the longest line between those is our halfway point. And then just draw that straight down. So of all the things we've drawn so far, this is the smallest. So when we talk about size relationships, this is the smallest thing that we have. And it's the equivalent to cutting this box in half or cutting this negative space in half. Okay, let's take the top left corner and let's go out. Let's do 1 inch going out to the left. And let's do 1 inch going out to the right. Now, if you look at this entire distance, 1 plus 1 plus half is 2.5. So this is the largest thing when you compare it to everything else that we've drawn so far. So if all this together is 2.5, let's go ahead and make this a perfect square. And a perfect square means that all 4 sides are the same length. So we're going to go up 2.5 on the left side and go up 2.5 on the right side, and then connect that. Okay, so we're going to use this structure, this long skinny rectangle and the square, as a container to draw a tree. So if you think back to the silhouettes, I talked about how often you would put something in a box. So this is that same concept. So if the trunk of the tree is in this, the bottom of it is typically the widest point. Trees typically get smaller or taper as they come up. And I'll start branching this out at some point so it goes up into this box. So try to make some kind of tree trunk. I don't care if it looks like mine. It doesn't have to be beautiful. Just, I want you getting used to the idea that when you're drawing, things have a top, bottom, left, and right. And if you can always think about that, you can help get those sizes correct, make it look the right size in the right place. And for the top, I'm just going to do something simple, just kind of little squiggly lines. And the top of the tree isn't going to perfectly touch the box all around because trees are just random and organic. So I'm just going to have some parts that come out and touch the box just a few times, but most of it isn't going to touch the box. So do some kind of simple shape to represent the edge of the leaves, the foliage of the tree. Okay, so we have a very simple scene with a little box sitting in the yard. We have a house and a tree. And all of these things have size relationships compared to each other. So, for example, the height of the house, the wall of the house, is the same as the height of the tree. The part of the tree that sticks out to the left is the same as the width of the box. The tallest thing in the picture is the foliage of the tree, or if you want to put these two pieces together, the tree is still the tallest part of the picture. This box is the smallest thing in the picture. So there are all these relationships going on between these different objects. And when you're drawing something, you have to understand those relationships, or you might make the house too big or the tree too small, and you won't get those things correct. Now, typically, when you're drawing something like a tree, you're not drawing a tree real life size. You can't draw a 50-foot tree on a 8.5 by 11 piece of paper. So you're always changing the scale of it. So to change the scale of something means that you're going to make it bigger or smaller. But the key thing, and often one of the more challenging things for students to kind of wrap their minds around, is that these size relationships don't change based on scale. For example, you're looking at it on the TV, and on the TV, this line and this line are the same height on the TV. But the TV is making that larger. So on the TV, it's probably more like 6 inches. So even though the TV is enlarging that, it doesn't matter how much larger or smaller, these two lines are the same. It doesn't matter the scale. So to kind of help you understand that, we're going to draw this picture smaller, and we're going to switch scales from inches to centimeters. So if you've ever worked with a map, they'll have a key on it that tells a scale, like 1 inch is equal to 10 miles, whatever. So we're going to switch from inches down to centimeters. So if we have 1 inch of negative space here, that means we would have 1 centimeter of negative space on this one. So if you look, take your other sheet of paper, bottom left-hand corner, go over 1 centimeter. Then we have 1 centimeter of empty negative space. If we're drawing this image, the next thing we have is this line going up. They are the same size when you compare them. This is 1 inch and this is 1 inch. If this is 1 centimeter, then the height of this should also be 1 centimeter. So even though this is smaller than the original, the size relationships have not changed. If this is 1, this is 1. So what I want you to do is continue redrawing this image, but you're drawing it using centimeters instead of inches. So whatever numbers we used up here, we're going to keep the exact same number, but we're just switching to a different scale. So in this case, we're switching from inches down to centimeters, which will make it smaller. So let's take a few minutes and finish drawing this out. When you get to the tree, try drawing the tree inside, but I'm not concerned if you do the tree exactly the same shape. So I'm more concerned that you have the boxes that everything fits into. Okay, I know a few of you are still working, and that's fine. I'm going to talk for a minute and explain the next part. That way everyone else can continue working. So what you should have when you finish is a smaller version of this image. And people realize it's the same idea, it's just smaller because the size relationships are correct. This box should be the smallest thing in the picture, so it is. This should be the tallest thing, and it is. The size of the foliage of the tree should be equal to the size of the walls of the house. The empty space between the house and the box should be the same as the empty space between the tree trunk and the house. So all of those relationships, if correct, make this look like a smaller version. So what I'd like for you to do on the back of these, or if you need to get new paper, that's fine. I want you to make a simple image with 5 shapes, 3 squares and a rectangle, whatever. And plan on drawing something in each of those. So for example, and I'll just give you a few ideas, you could maybe do a flower using the same technique as we did with the tree. And I'm doing this real quick. You might do letters. So you have boxes for each letter that you are creating. So what you put in the boxes isn't as important to me. I just want you to get used to thinking about boxes contain the objects that you're drawing. But I want you to make a scene that has 5 shapes, whether they're boxes, triangles, whatever. And you're going to make a large version So as you draw, you're going to start from the bottom corner. You're going to decide how much empty space there should be, and you're going to draw the shape. Yes. No, good question. So if I wanted to do, say, a bird flying up in the air, and I have a little box for the bird, I might decide that I want to go over, we'll say I go over 2 inches, and then I'm going to go up 3 inches. So by going a certain amount of distance left or right and a certain amount of distance up and down, that can help me have it floating out in the middle of space. Does that make sense? And then my bird might fit in a 1/2 inch by 1/2 inch box. So something like this. And then my bird, well, I should have made maybe I'll put 2 birds or a group of birds flying fit in that box. Does that make sense? So you're going to make 5 shapes, and I want you to do this the same way that we did it together. Start in the bottom left corner, decide how far over, write down how far it is, go up, write down how far it is. So that way you have all the numbers on this piece of paper. You'll have a large drawing that you've created. There'll be things in your boxes. You'll have the numbers using inches. And when you finish those 5 shapes and drawing the things in it, you'll go back and make a smaller version in centimeters. So by having the numbers the first time, you can just look at it really quickly and see what size things are. Does that make sense? Okay. Any questions? So we'll work on that for the rest of class. We'll see how far we get. Some of you may or may not finish, but we'll go from there.